All right, so today we're going to write quadratic equations given certain information about those equations. So in example number 1, we have roots of 3 plus I over 2 and 3 minus I over 2. Now, when we're writing a quadratic equation, we need to remember that we have x squared plus the sum of the roots times x. Remember when we were factoring, we were looking at the factors that would add up to that coefficient, and then plus the product of the roots. So again, remember, when we were factoring, we were looking at what numbers are going to multiply, basically to give us a product to give this number, and add up to give us the sum for this number. Okay? So we already have those two numbers, so we want to figure out what these are going to be. All right, so when we do that, we need to find the sum, so we add the two roots together. So we have 3 plus I over 2 plus 3 minus I over 2. So we have all over 2. We have 3 plus 3, which is 6, and then the I minus I, they're going to cancel. So we end up with 3 as our sum. So that's the number that's going to go there. Then we do the product, and we multiply those together. So we have 3 plus I over 2 times 3 minus I over 2. Well, we know our denominator is going to be 4. We have 3 times 3, which is 9. 3 times negative I, which is negative 3I. I times 3, which is 3I. And then I times negative I, which is negative I squared. All right, now when we simplify that, we have a 4 on the bottom. Our 3 i's are going to cancel. Remember that I squared is negative 1, so we have negative 1, so that's really plus 1. So we have 9 plus 1, which is 10. And that will simplify to 5 halves. All right, so now our last step is to put it all back together into the equation. So we have x squared plus the sum of the roots, which was 3 times x, plus the product of the roots, which was 5 halves. And if we want to put this in standard form, we just multiply everything by 2. So that can transform into 2x squared plus 6x plus 5 equals 0. And you can check your answer by, obviously it's not going to factor because we didn't have whole numbers as our roots. But we can use the quadratic formula, or we could complete the square to check to see if our answer is correct. Now let's take a look at example number 2. Find the roots of 2y squared plus y minus 5 equals 0. Check your answer by using the sum and products of the roots. So we're going to take a look at the original equation, and we could use several different methods of doing this. The two most likely would be completing this square or using the quadratic formula, because it doesn't look like it's going to factor. So let's use the quadratic formula. So remember, quadratic formula is negative b, so here's a is 2, b is 1, and c is negative 5. Okay, so remember, negative b, so negative 1, plus or minus the square root of b squared, so we've got that 1 squared, minus 4 times a, which is 2, times c, which is negative 5, all over 2 times a, which was 2. So then we simplify this. So y equals negative 1 plus or minus. Let's see, that's going to be 1. Negative 4 times 2 is negative 8. Times negative 5 gives us positive 40. And all over 4. And let's just simplify that a little bit further. And that becomes a square root of 41 all over 4. All right, so those are the two roots. We can write them out separately as well. Let's go ahead and check our answer by finding the sum of those roots first. So let's look at the sum. we have negative 1 plus square root of 41 over 4 plus negative 1 minus square root of 41 over 4. All right, so negative 1 plus negative 1 gives us negative 2. Our square roots of 41 are going to cancel out. So we have negative 2 over 4, which gives us negative 1/2. Okay, now let's take a look at the product. Okay, so we're going to take the negative 1 plus square root of 41 all over 4 and multiply by negative 1 minus square root of 41 all over 4. All right, so now we need to distribute that to multiply it. So we have negative 1 times negative 1 is 1. Negative 1 times negative square root of 41 is positive square root of 41. Square root of 41 times negative square root of 41, or square root of 41 times negative 1 is negative square root of 41. And then square root of 41 times negative square root of 41 is negative 41. And then 4 times 4 is 16. So let's simplify that a little bit. And we get, sorry about that, these two are going to cancel. So 1 minus 41 is negative 40 over 16, which will reduce to negative 5 halves if we divide the numerator and the denominator by 8. So now we just plug those in. And we say, okay, x squared plus the sum, negative 1/2 x, plus the product equals 0. So now let's get rid of all the fractions by multiplying everything by 2. So we have 2x squared minus x minus 5 equals 0. And was that the original equation? Yes, it was, except I changed the y's to x's. That's not that big a deal, but be careful with that. I don't want it to confuse you later. So really, these should all be y's, but we did get the same thing, so we know that this answer is correct. All right, now let's take a look at example 3. Find a quadratic function with minimum value negative 1, whose graph has x-intercepts 1 and 3. So that means our roots are 1 and 3. So let's take a look at the sum. 1 plus 3 is 4. Okay, and then let's look at the product. 1 times 3 is 3. All right, so we know that we're going to have an equation that is y equals, and we're going to have some number in front, minus, or x squared minus the sum, which was 4x, plus the product. Okay, so now we need to figure out what that a is. Okay, but we know that the minimum value is negative 1. Okay, so the vertex, the y value of the vertex is negative 1. So let's take a look at that. All right, so we know that the y value of the vertex is negative 1. Now remember, the axis of symmetry runs right through that vertex. So our x-intercepts have to be equidistant from that axis. Okay, so these two points have to be the same distance away from that vertex, from the axis of symmetry that goes through the vertex. So if they're the same distance away, we can add them and divide by 2, and that will give us the x value. So we have 1 plus 3 over 2, so that's going to give us 4 over 2. So we know our vertex goes through the point to negative 1. Okay? So if we know that the graph has a vertex of 2, negative 1, we can plug that into our equation and find what that a value needs to be. So we have our y value is negative 1. We're trying to find a. We know our x value is 2, so we have 2 squared minus 4 times 2 plus 3. So now we can say, all right, Well, 2 squared is 4. So we have 4 minus 8 plus 3. So 4 minus 8 is negative 4, plus 3 is negative 1. So now if we divide both sides by the negative 1, A has to be 1. So our equation is y equals, and the A is 1, so you don't really have to write that. And there's the equation of our graph. Now, if our vertex had been something other than negative 1, that A value would be something different. All right, let's take a look at example 4. We have a situation here. We have a rectangular dog kennel, and it's to be constructed alongside a house with 60 meters of fencing. If the house serves as one side of the kennel, determine the greatest possible area that can be enclosed. Well, let's take a look at this. First of all, we know we need a rectangle. So let's draw a rectangle here. All right, so we've got a rectangle. Okay. Now we have 60 meters of fencing. Well, to maximize that fencing, we probably want to make sure that the house is on one of the longer sides of the rectangle. So let's say the house serves as that side. So these 3 sides are going to be using that 60 meters of fencing, and then the house will serve as the other side. So let's say that the width is x, okay? And we know, and we can just say that this is y. So we know that that 60 meters is equal to 2x plus y, right? Well, if we get y by itself, we have 60 minus 2x. So we really could replace this y with 60 minus 2x. And now we have everything in terms of x. All right, so now we need to find the area. And remember that area is length times width. So we have x times 60 minus 2x. So now let's take a look at what our roots are going to be. So 0 equals x times 60 minus 2x. And so each of those can be set equal to 0. So x equals 0, and 60 minus 2x equals 0. So we have x equals 0, and then we have negative 2x equals negative 60. So x equals 30. Now remember, our maximum point is at the vertex, which is halfway in between these two x values. Okay, so the maximum area is going to be halfway in between these. It's going to have an x value that's halfway in between here. So we have 0 plus 30 over 2 is going to give us 15. So when x is 15 feet, that's going to maximize our area. So let's take a look at what that area would actually be. So we're going to plug 15 back into our equation. So we have 15 equals 60 minus 2 times 15. So we have 15 times 60 minus 30. So 15 times 30. So our area is 450 square meters. That is the maximum area we can have given those circumstances.